Okay, today we're going to continue elimination. Yesterday we did some easier problems, which always turn out really nice because we have that exact sign. They have an opposite sign, so we have a 2x and a negative 2x. Today we're going to see the case where we'll have no opposites. So if we don't have any opposites, what we're going to have to do is create those by multiplication. The way we're going to do that is by choosing numbers that when we multiply will give us numbers that will be opposites. And then what we'll do is continue on the same way we did yesterday, where we add the equations together, and then we'll plug that value back into the original and we'll check our answer. So in this problem, it's similar to some of the ones I finished up yesterday with. I always like to add these together, so some people talk about subtracting them, but I just like to talk about adding. So if only this was a negative 2, these two would cancel out. So what I've now done is I've made this one negative, so I have to change all the signs in that equation, which makes them all negative. These cancel, and I get negative 2x equals, when you add those together, you get negative 10. Divide by negative 2 on both sides, and we get x is 5. I'm going to use the first equation again, and I'll take that number, x, and I'll plug it in for the x value. So I have 3 times 5 plus 2y equals 27. I get 15 plus 2y equals 27. And then I will subtract 15 off both sides, which gives me a 12. I'll divide by 2, which gives me a 6. It gives me the ordered pair 5, 6. And then what I can do is check my solution. So I can put 5 in here and 6 in here. I can use the negative signs, or if I don't have to, I get 25 plus 12, and 25 plus 12 is 37. So I can feel confident that this is my answer. In the next problem, it's not as simple. I can't just change the sign to be a negative. Nothing's going to fall out. But I always like to say, if only I could make, I have a negative 3 here, and if only I could just put a 3 right here in front. Well, I can by multiplying everything times 3. If I could just put a 3 right there in front, I'd have a 3y. So I'm going to put times 3 on each one of these. And I like to write it above each one of them. That way I don't forget to multiply one of them by 3. The first equation we're not going to change at all, so I'll just write it off to the side. And the second equation I'm going to change to be 12x plus 3y equals negative 15. What that does now is when I add these together, that creates 0. Here I get 14x equals, these two add together to give me negative 28. So I'll divide by 14 on both sides, and I get x is negative 2. Pick one of the two equations to plug that back into. I think I'm actually going to pick the second one this time just because it looks a little bit simpler. And I'm going to take and I'm going to plug that back in for my x value. So I get 4 times negative 2 plus y equals negative 5. 4 times negative 2 is negative 8 plus y equals negative 5. So when I solve this equation, I would add 8 to both sides, and I'll get y is 3. So my answer will end up being negative 2. That's my x value. My y value is 3. On the next problem, if I look, nothing's really that easy to get rid of. I can't get rid of the 4 just by putting in this as a negative 4 because I can't make this a negative 4. So what I have to do is I have to start thinking about multiple. One of the things that people find the easiest to do is just kind of flip-flop these coefficients. So what I could do is I can say, well, this is 3 and this is 4. So I'm going to multiply all of these times 3, all of these times 4. Now the one problem with doing that, I'll show you. So we get 12x minus 9y equals 69. Down below I get 12x plus 16y equals 44. Well, now I have two positives and I need one of them to be negative. So what I really wanted to do was actually multiply by a negative 4 everywhere. Or I could have just changed the signs once I came over here. So what happens is these create 0. This gives me negative 7y equals, this is a 25, and then oh wait, here's a mistake. I apologize. I nearly made a crucial mistake. This is actually a negative 9. So what I really have here is a negative 9 plus a negative 16. 15. I always have to be careful of those negatives. So I end up getting a negative 25. So when I divide by negative 25 on both sides, I get y is a negative 1. I'm going to go ahead and pick the second equation to plug this back into just because it's all positives, and I like all positives. So I'm going to take and I'm going to plug this back in for the y because that's what y equals. So I have 3x plus 4 times negative 1 equals 11. So when I solve this equation, I have 3x plus negative 4 equals 11. Add 4 to both sides. 3x equals 15. Divide by 3. And x is 5. So I'm going to get my answer of x comma y. And I'll go ahead and circle that. And I'll check my answer by plugging those back in. I already plugged it back into the first one, or the second one, so really all I need to do is check the first one. So 5 times 4 is 20, and then negative 3 times negative 1 is a positive 3, so I do end up with 23 as my answer. Alright, again, we're back to doing some more elimination problems. If you look at your columns here, nothing falls out right away. You always want to check to see if you add things together, if things will just fall out. The next thing you want to do is look for the easiest way to come up with one of these answers. On this last problem, there was no easy way. You can't make the 3 a 4 and you can't make the 4 a 3, so we ended up flip-flopping the coefficients. Now I could do that on this problem and flip-flop these coefficients and multiply this by 10 and then multiply this one by 4, but it's going to create a lot more work. If I just recognize that sometimes I have multiples of the number, so I can make this 3 a 6 by multiplying it by a 2, and I actually want to multiply it by a negative 2, so I get a negative 6. Then I'm going to get something to fall out. So you always want to kind of look for multiples. So I'm going to multiply everything times negative 2. Now there is more than one way to do these elimination problems. It just depends on what you pick. Like I said, you could flip-flop the coefficients. You're just going to end up with a lot bigger numbers than somebody who just does it like this. So when I multiply by negative 2, I end up with a negative 8x, a negative 6y, and a negative 8. And this bottom equation just stays exactly as is. So now when I add these together, I get 2x. Those fall out and I get 0 equals 1. I'm going to divide by 2 on both sides, and I get x is 1/2. So then what I'm going to do is I'm going to go ahead and pick the first equation because it looks simpler to me, a little smaller numbers. I'm going to take and plug that in for the x. So I've got 4 times 1/2 plus 3y equals 4. So half of 4 is 2 plus 3y equals 4. I'll subtract 2 off both sides, and I get 3y equals 2. Divide by 3 on both sides, and I end up with 2/3. This is the correct answer, even though we ended up with fraction answers. That's okay. Sometimes our intersection point doesn't come out to be whole numbers exactly. In the next problem I have here, I want to go ahead and I want to say, all right, the easiest thing for me to do would be to say, okay, if only this was a negative 2, and so that's what I'm going to do, is I'm going to multiply everything times negative 2. That will be the easiest thing to do. So I get 2x plus 8y equals 10. The second one reads then negative 2x plus negative 8y equals negative 10. Well, when I do this, actually everything cancels, and so I get 0 equals 0, which means my answer is infinitely many solutions. When I get a true statement, my answer is infinitely many solutions, meaning they were really truly the same line.